Hello, everyone. I think we can get it going. I still see that people are coming through the doors. So let me first introduce myself. My name is Fedor Korotkov. Unfortunately, Viktor didn't make it to the conference. He and his lovely wife just had a new baby, so he stayed home. So cheers, Viktor, if you are watching live or in recording. And in the meantime, while some people are still coming, I'd like to first ask the audience, how many of you have edited a YAML file in the last month? Can you raise a hand? Okay, awesome. That's for the record, for those who are watching, it's probably like 95, 99%, almost everyone. Okay, awesome. And what about, are you using Kubernetes at work right now? And what about people that are planning to use Kubernetes in 2020? Okay, so I'd say pretty much like 80–85% people using it right now, and almost basically in the end of the next year, everyone will be using it. Okay, awesome. So I think everyone, like, doors are closed, so we can start. First of all, I want to set the expectations for the talk. It's not rocket science. We'll literally take a look at only 3 features of Kotlin in order to achieve a very flexible DSL for interacting with Kubernetes, and then I hope you will enjoy the demo in the very end. But first, I will start with some meme reviews, because I know it's second to the last talk on the last day of the conference, so just let me try to cheer you up. And since everyone knows what YAML is, and you have edited it in the last month, you know that YAML is indentation sensitive. So you actually need to keep an eye on your indentation and make sure that everything that you're writing in YAML is aligned. And what is the best way of making sure that everything is aligned is just like adding a ruler to your monitor. But this is a really good life hack, actually. I mean, I would imagine that some people will use it. And just a matter of fact, there is now a special position, which is like senior YAML engineer. I know the title is a little bit fun, but this is an actual position open. And as you can see, it's all about doing infrastructure for AWS. And yeah, you will need to edit a lot of YAML files. And the description of this position also involves a little bit of Go for some tooling around the infrastructure. But yeah, you will probably full-time do YAML. And finally, I know that we're going to talk about infrastructure as code a little bit later down the talk, but I want to just give you a small preview of what this kind of YAML files can look like for infrastructure. As you can see, it doesn't look like YAML very much, because you can see there is some templating engine involved to do the injection, as well as you can even have imperative if statement in your declarative by nature YAML. And also, you have bash injection. So on this small example, this is real example from Kafka Helm chart. You can see that you basically have kind of 3 languages, 2 languages and templating. So when I see something like this, I'm speechless, like right now. But then I always remember in this kind of picture, because this is literally something weird happening. Okay. Hopefully you like the memes, and it's sometimes better to look at the problem through jokes first, because then it's much easier to admit the issue and finally start working on it. So, but now let's start to be a little bit more serious. So let's first of all learn how YAML came around, because for me, I always knew YAML. I used it for small things, and then this like boom of infrastructure as code came around, and now YAML files are not like they used to be. So YAML initially was released in 2001. It was called initially yet another markup language, but it was like quickly repurposed into YAML ain't markup language. So you can see there was a like confusion from the very beginning. And from the wiki, it's like YAML is commonly used for configuration files. But basically, you just want to declare stuff. And as we saw in the preview of some YAML files that are popular right now for infrastructure, it's not declaration anymore. It's like, you actually try to do like if statements, for loops, and so on and so forth. So it's not like it was intended to be. And unfortunately, YAML is not going anywhere because it's actually pretty good when it's like small examples for like presentation. It's pretty easy for human eye to understand when it's small, when you don't need this like ruler. So if it's like a few dozen lines, it's actually pretty nice. But there are some real problems because as you also all know, YAML is not only indentation sensitive, it also doesn't have built-in mechanism for custom types. So you only have primitives like numbers, strings, lists, and objects. And therefore, you need to somehow parse it and either deserialize or translate into internal representation of your model that you use. And sometimes people make mistakes. And like in this case, for example, a version was parsed as a number instead of a string and was used actually in a string. But since it was a number, it was rounded down. So instead of 110, you got 1.1. So you, instead of upgrading one version, like bumping one version, you also actually like downgraded 8 versions, which is not nice. It's good if your like tests would have find it. And just a sneak peek. Anyways, so there are tools around it, right? So there are like linters that you can have to validate your YAML files to make sure that everything is according to the documentation, to the objects that you are expecting. And probably you can also relate to this experience when you have like 2 windows. One, you're editing the YAML file, and the other is documentation, and you're just like moving back and forth because you don't have completion. You need to always to check what's going on, what kind of fields there are. And but the problem here is that it's not out of the box. You need to configure something. And all the linters, these tools are not particularly good at recovering from errors when you have almost valid input. For example, you probably all use in JetBrains IDEs. You know how good they are at doing completion when even your code is not fully like compilable when there are errors, because JetBrains, they tend to care about how the custom parsers, they recover from such errors. So yeah, you can, with these tools, you can easily get into a position where you have like one mistake, but then like parsers breaks and there are like just too many errors. And this is like a real case that like happened to me. And finally, I need to mention that there is actually a schema for YAML files. It's called JSON schema. So why is it JSON? Because from YAML specification 1.2, it was actually started to be compatible with JSON. So any valid JSON can be easily translated into a valid YAML. And you probably may notice that JetBrains IDEs actually started supporting this schema, even though there is no final draft for the JSON schemas. And in your IDE, you can see in the bottom right corner that now your IDE can detect the schema and then provide your completion and validation, which is nice because it's, again, you want something that works out of the box, so you don't need to configure this, and it works pretty nicely. Okay, so I want to first admit that YAML is great, as I mentioned, but for small things. And we will talk a little bit right now about the infrastructure and Kubernetes as well, of course, before jumping into the Kotlin side of the talk. So, as I mentioned, this infrastructure and YAML files for infrastructure, they are not feasible for humans anymore. They're literally screens and screens of different configurations. When you have YAML, you have some templating and of course bash scripts. So this tweet pretty much describes the issue, because just remember how, if you can remember, how working and how creating applications, how development process was different in 2001. There were not so many abstraction layers like right now. You had Word was simpler. Right now it's impossible to catch up with everything that's going on. And with more abstraction layers, you are getting more and more, not only your application is growing, but also how you do the infrastructure and all the tools around it are also getting more and more complex. So let's see an evolution of YAML in a company. So probably when you just start something doing, you have one server or something like this, you can pretty much do everything with scripts. You don't need YAML, you can do some deployments, you can copy some jars, or Docker can start Docker locally on the machine, and you don't need anything when you have just a few of servers to maintain. Then, when your fleet is growing, you start using something like Ansible to do the configuration of your machines. And then finally, when you do get fancy and start using Kubernetes, you end up with Helm chart. You use some Helm charts, you write some Helm charts, and I think that the next step in this evolution can be actually Kotlin DSL. So I know it seems like everyone pretty much knows about Kubernetes, so I won't spend a lot of time talking about it. I just want to stress one thing about Kubernetes. So Kubernetes is a container orchestration framework for deploying your applications. And the interesting and the most important part for this talk is that Kubernetes API is actually declarative. So what does it mean? So in the world of Kubernetes, you don't specify how you want to deploy things. You specify that you want a deployment. You just create a deployment, and Kubernetes makes it happen. So for example, you create a deployment for your application with let's say 5 replicas. You want 5 containers, so you just create it, and Kubernetes sees that new declaration of a deployment. It understands that it needs to find resources for 5 new containers. It finds available resources, starts them, makes health checks. If you also created, for example, a service object, then it will put DNS records and so on and so forth. But we need to also mention that the API that Kubernetes is using is actually JSON-based. So in your pipeline from your infrastructure as code to actual infrastructure running, there are so many steps now. You have YAML with some templating that gets translated into a huge YAML. Then this huge YAML is translated into JSON. And this JSON is finally submitted to Kubernetes, which can make validation for if it's correct or not. So pretty complex stuff. And if you Google for Kubernetes YAML, you're getting almost 2 million results. So it's really, I think infrastructure as code, and particularly also Kubernetes, is the most growing area where YAML is using right now. And like the usage there is, I think that the problems we're trying to solve, they outgrew the capabilities that YAML is providing to us. But again, I mentioned that YAML is great when it's small, but what should we think about when we have, we're scaling our like infrastructure, when we have several teams, each team has like several configurations that they maintain. So we think about how to avoid copy pasting of your YAML configs. That's why you probably use like templating. You try to provide primitives, and you try to provide customization for the team so they can tweak settings as they are required for their needs. And also how to test these incremental changes. And if you just look at these statements, it's basically just same as what you're doing when you are coding in Kotlin, for example, right? You also want to avoid copy pasting by having like common libraries. You want to use third-party libraries. You want these libraries to be very flexible, so you can customize behavior and so on and so forth. So this is probably why it's like called infrastructure as code, and you actually want to code something, but then you end up with the YAML. So here's a small example of how a simple YAML config looks for Kubernetes. So this is an ingress example. Ingress is a way to expose your internal services from Kubernetes to outside world. So that's pretty nice, right? As I mentioned, like YAML is great for small things. When it fits on a slide, it's great, you can see it. But probably by that time you can proxy it to the issues when it's like hundreds of lines. And will it be nicer if the experience, instead of that, you will do something like this using Kotlin? So as you can see, out of the box, you will get completion and type validation and just, in general, experience that you are used to while programming, instead of like switching between browser and your editor because there is like no completion, and you don't need to configure anything extra. And as you can see, there's like special types like int or string, because it like can be either can be like name or an actual port number. So so how does it work? This Kotlin DSL library is actually super simple. So there is already a Java Fabricate library that provides you with a client that can talk to Kubernetes and model objects of the Kubernetes API, the standard one, like deployment, like stateful set, like persistent volume, and so on and so forth. So what this project does, it does two things. First, it has a generated DSL for the standard types that you just saw, the ingress one. And then it's also possible to, with that Kubernetes Kotlin DSL project, to generate these fabricate types from a CRD. So CRD, it stands for Custom Resource Definition. So in Kubernetes, you have objects that you create, and there are standard ones, as I mentioned, deployments, stateful set. But some companies, they do create their own abstractions that you can deploy to Kubernetes. For example, Confluent, a company that Viktor is working for, they have their own Kafka operator. So they bring the same experience to Kubernetes. So you have Kubernetes now knows that there is a thing called Kafka, and you don't need to manage yourself like stateful sets. You don't need to manage like persistent volumes and scaling, all of that. The operator takes care of it. You just create a Kafka object, and you just specify how many replicas do you want. So let's see those 3 language features that I mentioned that is used in the library itself. So the library itself is just a bunch of generated functions. One kind of these functions is builders that help you to build these new objects. And in order to build it, it's like simply uses higher order functions with the receivers, which allows you to instantiate a new object and then just apply the modification that you passed along the way. And for also, excuse me, that it's not the pretty Kotlin, it's generated Kotlin, so it shouldn't be pretty. It specifically generated this way because even though names of the objects that Kubernetes are using are unique, fields of those objects are not. So to avoid collisions, the generated code is not that pretty, but you'll get a nice experience in the IDE afterwards. So, and the second thing is how you do, and the second kind of functions are the extension functions to do modification of these objects that got created. And this is pretty much the same. It's a higher order function with the receiver, but now it's an extension. And you can see that it simply checks that if a field is initialized or not, and then applies the modification. As I mentioned, no rocket science, it's super simple. But now let's see how this thing can be applicable in your deployment. So now we'll do demo. So how much time do we have? Oh, we have plenty of time. So I've already created a Kubernetes cluster, which does have this confident operator deployed. So you can see that now Kubernetes knows about Kafka clusters. So you can get it, and you can also see schema of it. So as you can see, it defines the schema, it defines what kind of properties there are, and so on and so forth. And this output can be used by the Kubernetes Kotlin DSL project to generate these fabricate types, and therefore, after that, generate the DSL as well. So it's a good time to mention that the CRDs, the operators that are created, they can be written in any language. This one, for example, I think is written in Kotlin or Java at least, but most of them are in Go. And by just generating the necessary custom DSLs from the API response from the schema, it makes it much easier. So you don't need to parse, Go or try to do some type inference from Kotlin. Okay, so you can see I have this Kubernetes cluster on Google Cloud, and you can see in workloads, hopefully it will load. Yes, in the workload we have the Kafka, so like this CRD, the operator that handles everything, and there is also another CRD for Zookeeper and for this manager. So now let's switch to the Ontology and see some use cases that we can achieve by using the Kotlin DSL, and how we can avoid copy pasting, how we can make some extensibility, and so on and so forth. So here it's an example. This file is an example of how application configuration file is created. So we can create a secret for our, Kubernetes secret for our deployments to use. And here in this file, I want to highlight one particular thing, that here we're checking if a Kubernetes cluster that we're trying to deploy to if it already has a Kafka, because you can either have a Kafka that you run your own, or you can use some cloud solution that the Kotlin as a company they also provide. So here we check if there is already Kafka, then we will grab the specification how to connect to this existing Kafka, or otherwise we will check that application, the properties file that was provided actually contains necessary information that we need. So, and right now, if you think how you can do the same with the regular Helm charts, I'm not sure how you can do this, because you probably will wrap your already existing Helm chart in some other script, so it doesn't sound pleasant. So let's try to create this new configuration file that our application will use. Again, this secret contains configuration how to do like port numbers, the Kafka address. So let's create the application config. Okay. Yeah, you have a machine with 8 cores and it doesn't work that fast. Okay, awesome. So we now created the config. We can go through the UI and see that we actually have the config. Here is it, application config. Now let's see how we can deploy things. So let's go to the Clift deployment. Okay, where is it? This one. So we will see what this application look like. It's like an Uber, like a Lyft. Lyft is also a very popular ride-sharing application back in the US. So as you can see from our deployment example, we already have an abstraction here. We have a base deployment. So if we go into the base deployment, we see that we can start creating special abstractions that we can reuse. And we can, for example, if you have an infrastructure team, this infrastructure team can create them. For example, they can create a common abstraction for connecting login aggregation to your service, or some metrics aggregation, or how to connect to a database, and so on and so forth. For example, we internally at Cirrus have a similar base deployment, but you can also provide things like defaults, like how many resources a service requires. Is it more CPU intense, or is it more memory intense? For example, how many replicas by default it needs, how aggressive autoscaling should be. And it's all coming through constructor arguments, and each microservice can define their own and also do an easy modification. We will see back how Clift deployment makes the modifications. But right now you can see that we only provide the service name that we want to deploy and some default amount of replicas, which is by default is 1. But you can see that this is pretty much, we can extract it. And since it's Kotlin and it's an IntelliJ, we can actually do refactorings. And we can extract this. And then to this scope, and IntelliJ will find the overrides. And then we can extract it and call it common labels. No, there was a typo anyways. But you get the point. It's much nicer experience to edit infrastructure that way rather than YAML. So, okay, so now let's go back to the Cliff deployment that we have. So we use the base deployment to get the base deployment configured with all the necessary labels and replicas. Then we can override what kind of containers do we want, and we can also get the config from the secret that we already created on the previous step. And now let's do the deployment and finally see the demo. Okay. So let's now deploy. Hopefully this time it will be faster. Yeah, wonderful. So now it's deploying, and if we'll go to the workloads, let's use UI for more for visualization. So here we have the Cliff deployment that we just added. Since we defined only one replica, we have one pod going. So let's go back here and do port forwarding. I don't have the ingress for the matter of this presentation, but we could have done it. And okay, what's wrong with it? Okay, got it. Okay, port forward. Now it should be running. Let's switch here. Okay, so it's a ride-sharing application that uses Kafka in order to stream position of both rider and driver in real time. So here on the left-hand side, we have the rider application that like this rider is waiting outside of the Bella Center. Then on the right-hand side, we can put ourselves somewhere. Let's put us maybe here. And then, oh, it's probably, there are two people now. It's probably because I ran the demo beforehand and I put it there. Let's, for the sake of the demo gods. Oh, crap. Okay. Okay, once again, I ran it multiple times. Okay, let's put ourselves somewhere here, and then we choose this person instead of the other one. So you can see it's like in real time start driving. We don't see our ghosts from the previous ride, but we see the ghost car. Anyways, again, I'm not front-end engineer, so I'm not sure what's going on there. But you get the point. It's a pretty nice application. And while the ride is going on, we can explore some other use cases. So as I mentioned before, when you do infrastructure, unfortunately, you not only need to declare this, like how you deploy application and how your infrastructure is looking like, but sometimes you need to also write some scripts to understand what's going on in your cluster. Just imagine if you like have a big company, you adopting DevOps, and then every team like has freedom to deploy whatever they want, like almost whatever they want, using the primitives like this base deployment that infrastructure team is providing. You or like infrastructure team members, they can for example, want to know where some secrets are, because secrets in Kubernetes, it's a special beast. So when you, for example, update your deployment, Kubernetes will see that the deployment is updated and will restart the containers and will do the rolling deploys and will do it fancy. But for secrets, if you just update secret, it won't update it. So for example, if you need to do a rotation of some certificate in your organization, how do you know where it is used? So in case of using, for example, Kotlin DSL, you can actually write additional scripts that will help you to look up and do some analysis of your existing cluster. So for example, this is an example of how to do basically find usages of a secret in your cluster. This script is basically goes through every deployment, and for deployment it checks volumes, and if a volume was created from a secret that we're looking for, it will report it. So if you're on infrastructure team, it will be super easy for you to understand which teams should be notified about this issue. And there are like many, many more examples of that. For example, internally at Cirrus, because we're targeting Kubernetes, we create Kubernetes jobs for each CI task. There are many modifications that we can use. For example, if your particular task is not very important, it's not a deployment, it's not a master, it's some PR task, then it can have smaller priority, or it can use preemptible VMs on Google Cloud. And preemptible VMs, they are like 80% cheaper, so you get the benefit. And you can have, first of all, a bunch of helper functions, like normally you have in your day-to-day programming life. You can have some things to share, as well as use normal for scripts and if statements, not like in the YAML file that we saw before. And I think this is pretty much it. We have 5 minutes left. I don't know if we do Q&As or we don't. After the talk, yeah, I'll be here. And if you are watching live, I'm also available on Twitter, so just tweet at me. And yeah, thank you.